Well, welcome to today's session on performing in a pandemic. My name is Annette Jimenez Gleason, and I'm a program officer with the Rochester Area Community Foundation. The foundation is a proud partner with the Rochester Fringe Festival to present this next chapter in our webinar series focused on COVID-19 and the arts. A special shout out today to members of the New Jersey Theater Alliance who are with us. Today's session will be led by Dr. Stuart Weiss, who is an internationally known expert in the fields of business continuity, disaster, and pandemic planning. He is the founder of Intelligent Crowd Solutions, a consulting company specializing in business continuity planning and crisis management for special events and event production clients. He serves on numerous COVID-19 task forces, looking at business reopening and reimagining, and is board certified in emergency medicine and pediatrics. Dr. Weiss's presentation will be followed by a Q&A portion led by Erica Fee, producer and executive director of the Rochester Fringe Festival, and Simeon Bannister, vice president of the foundation's community programs department. During today's session, you will be able to add your questions in the chat tool at any time. The webinar is being recorded and will be made available with closed captioning. And in attendance, we do have members of the media. With that, I turn it over to Dr. Weiss. Thank you so much for being with us today.
Oh, you're so welcome. And I apologize to everybody for the delay in the start of this, the few minutes. We're having technical issues on my end here. Doing everything remotely nowadays. I came into my office today and our entire computer system had blown up. So we put it all back together. I'm hoping, Annette, that this will work. Let me know if for some reason you're not hearing or seeing what I'd like you to see. So good morning, good afternoon, everybody. Welcome to the webinar. We have people from around the country and in other countries as well around the world. Today, I'm going to spend a few minutes talking to you about the status of where we are, and then we're going to talk about some safety precautions and the science behind it, and then we're going to drop into a conversation back and forth about some of the questions. We got a whole series of questions from folks from around the country in the performing arts area, and we want to start talking about questions and answers. Now, let me just start by saying there is a lot that we still don't know. And that's the problem, is that we don't know everything yet. And there's a lot of science that we are still trying to figure out. So I may not be able to answer all the questions based on science, but we have a lot of clients around the country and around the world that are looking at the same problems. So what I'm hoping to be able to do is share some of their thinking with you, and together maybe we can figure out what's the next best step. So let's jump right into this. And I want to make sure, Annette, can they see the slides?
Yes.
Oh, great. Okay, perfect. So I'm Dr. Stu Weiss. I'm the founder of Intelligent Crowd Solutions. There's our website. The letters after my name just mean that I am board certified in emergency medicine. I'm board certified in pediatrics, and I'm a certified business continuity professional. So I will skip through that. Okay, so we're talking about COVID-19, which all of you have heard, but some of you may not realize that COVID-19 is caused by the SARS-CoV-2 virus. So SARS is severe acute respiratory syndrome, and it's coronavirus number 2. SARS 10 years ago was SARS-CoV-1. Now we have, it's just SARS virus. Now we have SARS coronavirus 2. And an interesting tidbit about this that I always like to point out is here's a microscopic picture of the virus, and those spike proteins that stick out give the virus kind of like a halo around it, or a crown, and that's why it's called coronavirus, because of the crown formed by the spike proteins that are sticking out of it. So there's the SARS-CoV-2 virus that causes coronavirus disease, CoV-2 So it's CO for corona, VI for virus, D for disease, and it started in the year 2019. So that's the reason why we call it COVID-19 and SARS-CoV-2. Because I'm going to use those terms throughout this talk, and I want to make sure that everybody understands what they are. Okay, so let's talk about what is coronavirus? Coronavirus is part of a large family of viruses that are common in many different species, right? So if we, there we go, sorry, there we go. They're found in camels and cattle and cats and bats and lots of different mammals have coronaviruses. As in fact, bats have been found to have hundreds of coronaviruses inside of them. And cats, and we'll get to that in a little bit, but cats are specifically very susceptible. So those of you that are running zoos or areas where there are cats, you have to be really careful. There were some cases of tigers and lions getting sick in the Bronx Zoo here in New York. The first cases of house cats getting sick came from Europe, where house cats got really sick because they share the ACE2 receptor, the same receptor that we have that causes the virus to get into our lungs. Cats have a very similar type of virus, of a receptor, so they can get sick as well. Luckily for dog lovers, dogs do not seem to have the same ACE2 receptor. So dogs are not susceptible, although dogs can carry it in their nose a little bit. Most of you have, I'm sure all of you have already had coronavirus. Now, you haven't had SARS-CoV-2, probably, unless you're in that 5% of the country that already has it. But you've had coronaviruses because they cause the common cold in humans. So coronaviruses circulate all the time, which is why we have a bit of a head start in vaccine development, because we already know a lot about coronaviruses in general. We just don't know a lot about this particular coronavirus. And we think it came from bats, or most likely it came from bats. The proteins and the genetic material is very similar. It does need an intermediary host to get to humans, probably. As I said, there are 7 types of coronaviruses. The 2 at the top, the 4 at the top, the 2 alphas and the 2 betas are the ones that circulate every year. And then we have the other 3 that came out more recently, the SARS-1, the MERS, which came out a couple of years ago in 2012, and then SARS-CoV-2 virus. Right? So what's our current threat? Now, you know, most of you should know this. Hopefully you haven't been in a cave somewhere the last 5 months and just coming out right now. However, there was, as you remember, 2019 December, it seems like much longer than that, but it was just December of last year, 6-7 months ago, there was a cluster of sick people in Wuhan in Hubei province that was detected in China. Initially, most people had links to the Wuhan seafood and live animal market, and it's very interesting that the recent outbreak that we've seen the past week in Beijing also started in an open air food market. So that seems to be a place with lots of people and lots of animals and lots of ability to spread virus, at least in Southeast Asia. Right? A few weeks after that, in January, many people did not have a link to the animal market, and we found that we had person-to-person spread. And as I said, it probably came through from the bat, possibly into an intermediate host, which is the pangolin, or perhaps not. We're not quite clear, but a pangolin is a scaly anteater, but it was sold as for medicinal purposes and for other purposes in the market. So pangolin, maybe pangolin, we're not sure about that, but a lot of these viruses do require an intermediary host to jump to humans. So what do we know? We know that the incubation period can be up to 14 days. So that means that you could actually catch the virus, it could be growing in your body, and it could take up to 14 days for you to develop symptoms and be contagious. Most people get sick within 3 to 5 days, which is why there's some guidance that it talks in terms of that, but that the actual range tends to be 14 days with some real outliers going even a little bit longer, but 14 days is the number that we seem to talk about a lot. How does it spread? It spreads by a couple of different methods. And this is really important to remember because this has to do with the mitigation strategies that we talk about when we talk about how do we safely reopen. So it spreads between people that are closer than 6 feet due to droplets, and we'll talk about that in a little bit. So respiratory droplets is when a sick person sneezes or coughs or talks or yells or shouts or sings. They spread droplets. These are large particles, 100 microns. They settle to the ground pretty fast when they get to be that big, 20, 30, 40, 100 microns. They settle to the ground within about 6 feet. Then there's some increasing evidence that there are some people that spread this virus by respiratory aerosols, which are, and all these are aerosols, but aerosol particles are typically thought to be much smaller. So for those of you that know the science part of this, 0.5 to about 5 microns. And those size particles can go in and out of our lungs easily and can float in the air for really long periods of time, hours sometimes, right? And then the third way, which we think we're learning is a little less important, but still important, is through touching something contaminated and then touching your face. That seems to be a little less important in terms of how things spread. And what we are learning is there are asymptomatic or not yet symptomatic spreaders. You can actually spread it 2 days prior to symptoms, and you seem to be really infectious, spreading it sort of right in that time period, right before you start getting symptoms. So it's a little crafty virus in that it wants to spread itself even before the host gets sick, which makes it hard because previous coronaviruses that contain SARS and MERS, you actually had to have symptoms before you started spreading it. But this particular virus seems to spread before you can develop symptoms. So what are the modes of spread? And hopefully you're not watching this on a little phone, but you're watching it on a bigger screen so you can see this. But the first thing is actually the ballistic spray. And you can actually feel that. If somebody closer than 6 feet sneezes in your direction, you can sort of imagine those droplets coming at very high velocity right at your face, right? And that's one of the reasons why we want folks wearing face coverings. We want to stop that ballistic spread of droplets right into your eyes, because that is a perfect way, if you cough forcefully or sneeze, of spreading virus right into somebody that's really close. The second way is through the green dots, which are large particles, right? And those green dots actually are bigger than about 5 microns, and they, more like 20, 30, up to 100, as I said, microns, very small particles still, but they tend to settle out within about 6 feet. So they settle to the floor, and that's why we have the 6-foot rule here in the United States. Maybe a little less if for some of you that are in Europe, you're using 1.4 meters, which is a little less than 6 feet, but it's more or less 6 feet. Then the third way is the fine yellow dots, which are the small aerosol particles that can float around for a long period of time. And the last way is through contacted. So here, they're passing a phone or passing a script or passing a libretto or whatever it is, and it's contaminated. So you want to make sure people aren't doing that. Okay, so those are the way that we spread it. And one of the things that's really interesting, here's a study that was really interesting, looked at the number of particles as you talk louder and louder. So there's a lot of graphs on this. You can take a look at it later, but take a look at the graph on the right side. You can see that the blue line, which is really loud shouting or singing, puts out much more particles than the red line or the yellow line, which is quiet talking or intermediate talking. But that blue line, you can see the number of particles really gets much, much higher. Because when you're talking louder, you are projecting. So when you're projecting your voice, when you're singing, you are putting out much more particles, much more than when you're just quietly sitting, breathing quietly. But even at the quiet breathing, you are still putting out some amount of particles. But anyway, these graphs show that. Great study. You can take a look at it. If you need the study, just drop me a note. We can send it to you. Or you can download it from scientific reports. But it's a good study looking at particles and how increasing the volume or projecting your voice or singing creates so many more particles. Right? So why does it actually produce particles? Right? So let me give you a little bit of the science so you understand what's actually happening. Right? So in our lungs, in the very small air sacs, the alveoli, which are the base of the lungs, we have millions of them. Right? So our lungs, we have a big trachea, and then we go into bronchi and bronchioles, and as it divides into smaller and smaller areas, and then you get down to the alveoli, which are the little air sacs where the oxygen and carbon dioxide exchange into our blood. There's millions of those things. They're very small. And when you exhale completely, so when you're singing or when you're exercising or doing vigorous activity on stage, for example, when there's a fight scene or something that's very active and you're breathing heavy, when you exhale completely, those little airways collapse. They contract and they collapse. And on the surfaces is something that's called surfactant and mucus and some other things that keep our lungs lubricated. So when the walls of the air sacs and little tubes close, and then when you take a deep breath, they open, it's like forming a film over something. Imagine if you were to take a rubber band with some bubble solution, and then you stretch the rubber band slowly, you have that solution that still forms the beginnings of a bubble across the rubber band, right? So as you start to expand those little air sacs, you form a film of surfactant and mucus across, and then as you expand it more, eventually that bubble breaks and you get a little particle. And as you're inhaling, that little particle goes into your air sac, and then because it's so little, when you exhale forcefully, you shoot those particles out. And those little particles, because the SARS coronavirus is so small, those little particles can actually have hundreds or thousands of virus particles in them. So when you're breathing heavily and your lungs are opening and closing and opening and closing, you are forming many more of those little particles and you're putting them out. And that's the reason why when you're shouting or singing or projecting your voice or doing athletics, you're putting out many more particles. And what evidence do we have that aerosols actually seem to make a difference? A good article out of China talking about the spread in a restaurant. So let's take a look at a poorly ventilated restaurant where people were talking loudly. They were trying to get over the hum of a pretty full restaurant. They were eating, they had no masks on. And in this particular restaurant, let's switch to a slide you can actually see. I'm going to zoom in on the restaurant. You can see in this restaurant that they had, maybe a little hard for you to see, but on the right side of your screen, you'll see that there are 4 air conditioning units along the right wall, right? Along the straight wall on your screen should be the right side. That wall of the restaurant next to table 17, T8, T17, T16, and table T13, you'll see that there are air conditioning units, right? And in this restaurant, you can also see that there are exhaust fans around that were supposed to be on, but they were off. So you have a big box that's a restaurant with air conditioning units that are recycling the air and blowing the air across the restaurant from right to left. So it's kind of a perfect setup for a little experiment. So then what you do is you take an infected patient and you put them at table TB, B like in Bravo. So in the back left corner, table TB, table TA, index patient A1, right? You put the patient there and they're sick. And then because the air is blowing straight across, you can see that all of the patients that got sick were actually in that same area. So let's take a look, right? If you look at this picture, you can see the air, because all the ventilation fans were closed and they were recirculating the air, that all the people in the back got sick and none of the people in the rest of the restaurant got sick. And that's because of the aerosol flow from patient number A1. You can see that person, the air went to the left, circulated to the bottom, got sucked back into the air conditioner, got recirculated out. And that's why the guidance, this is one of the reasons why we talk so much about making sure that if you're in a enclosed space, that you actually have a lot of fresh air coming in and exhaust to take the particles out. And we'll talk a little bit more about that as we go along here. But anyway, this is a great study of what happens in a small enclosed space. But all those people in the back part in the blue section got sick, and none of the people outside of that area. And the way that it circulated, larger particles would have settled to the floor, whereas small aerosol particles would have floated. So there's lots of discussion it looks like aerosols at least play some role in the spread of this virus. There's been studies in hospitals that look at aerosols, that the particles spread in ICUs, and it looks like there's some particles that float in the air. So this brings us to choirs, because there was actually a lot of questions submitted about choirs. And choirs, so indoor choir practice is actually another perfect experiment to see whether or not aerosols spread. And this is really early in SKAGIT County, Washington, back from March. So if we take a look at this, you can see there was a 2.5-hour choir practice. They had a large group in one big room, and then they broke into smaller groups. Then they came back together as the large group. They had 6 rows of 20 chairs each. Each chair was about 6 to 10 inches apart. Of the 61 members that attended, 52 of them, about 85%, got sick, and 3 of them ended up being hospitalized, and 2 of those people actually died. So another good example of aerosols, people were filling up that closed space with respiratory particles. These particles were floating around, and as we're going to talk about, getting sick has to do with how many particles you get into your body. The way you get particles into your body is by the density of particles in the air, how many are in the air, and how long do you breathe them in. And we don't know what the actual infectious dose is for SARS-CoV-2, but you have to get a certain number of particles in your body for you to get sick. And these people exceeded that number because it was a relatively small practice place. They were singing, so they're putting out a maximal amount of particles. They're indoors, not great ventilation, packed together, perfect way to spread virus. Great study. Is a great article, and I recommend for those of you that have an orchestra to take a look, go search under COVID-19, I mean, Wired. Wired magazine did a really good article on orchestras, right? And they pointed, it's got great references in it, so go pull this article up. We can send you the reference exactly if you want, but if you just Google Wired magazine, you know, COVID orchestra, you'll get the article, right? So what's the problem with orchestras? Well, the problem, excuse me, the problem lurks in the back of the orchestra with the woodwinds and the brass, right? Other instruments, people can wear face coverings. They are, you know, perhaps the percussionists are exercising a little more. They're way, way in the back, but they can actually wear face coverings. But the woodwinds and the brass are the problem. So there's very limited data on this. However, there was one study where they studied vuvuzelas. Now, you may remember what a vuvuzela is, but if you think back to the World Cup, there was lots of people blowing these long plastic tube things. So there was actually a study, and we can pull this study up for you as well, published in PLOS One, that talked about the propagation of respiratory aerosols or respiratory particles by vuvuzelas. And they actually found that a vuvuzela is actually a perfect device for shooting at high speed an enormous amount of particles because it's a straight shot. It's a very narrow tube that goes for a long distance. People are taking really deep breaths and blowing as hard as they can to make a really loud noise, and they're shooting out 178 times more particles than people that were shouting. In this paper, in the experiment, they had people stand in front of a laser counter, and they had people shout as loud as they could, and then they had the same people blow a vuvuzela, and they found it was 178 times more particles in blowing a vuvuzela. So how does that apply to orchestras? Well, most instruments are not straight shots, but flutes are, and sometimes, and oboes and clarinets perhaps. Brass are less so. So the vuvuzela may apply to orchestras. I can tell you that there are several groups that are taking a look, a group out of Colorado, one out of Maryland, that's actually taking a look at instruments, trying to figure out what about aerosol particles. We're not so worried about large particles because the dynamics of a woodwind and a brass is usually you have a small entrance with higher velocity air and then a bigger exit with low velocity air. So big particles will generally settle out pretty fast. And also there's moisture in there. in the instrument that settles out particles, but it's the aerosols, the small little ones between 0.5 and 5 microns that we really worry about. Okay. So we worry about large particles and not so much large particles and aerosols. And again, this is a great article. So this is hard to see, and I apologize for that. You'll be able to get it more in the handouts if you download them after this. But you can see that people actually are interested in coming back. So on this chart, the 50% is people that are, well, I might come back, I might not come back. People higher than 50% said, I would definitely come to see these things if we had, once COVID-19 is relaxed, precautions are relaxed, I would definitely come to these things. And if you take a look, you'll see that they'll go to public parks and zoos, and some of them will go to museums. They want to come to sports arenas, a little less coming to community swimming pools and concert halls and movie theaters where people perceive them to be closed spaces. But people, in the most part, are wanting to come back to these activities. And if you take a look at what they want us to do, you can see that they're much more comfortable if we're outside, if we have hand sanitizers, there's not a lot of lines to wait on, there's good social distancing. Some of them wanted fever scanning and cleaning, but that's really down at the lower bottom of this. This is a great, there's a company called Impacts that's actually been following this for months. And on the bottom is the website that you can download this same graph and take a look. They do another survey every couple of weeks following the trends in cultural things. Okay, so let's spend the last couple of minutes before we get into a general discussion, talking about the safety precautions. And let me just grab a quick drink of water, excuse me. Okay, so when you start thinking about opening your facility, one of the things that you have to do is a risk assessment. You need to look at the risk. And because you want to limit the risk to make it as low as possible, we're not going to be able to make the risk zero. The way you make a risk zero is by closing everything. So right now, the risk of me getting COVID-19 at a baseball game, for example, is zero because there aren't any baseball games. But as soon as we start opening things up, the risk rises from zero, but the goal is to make the risk acceptable, to make the risk something that is the lowest possible thing. So risk has two components. Risk has hazard analysis, and what's the actual hazard, and what's the actual risk? How do you actually reduce that hazard? Sorry, so the risk has the hazard part, and then how do you reduce the risk of coming in contact with that hazard? So there's two parts. So let's talk about the hazard analysis part. So the hazard is SARS-CoV-2. We know that that hazard exists. It's been with us for now 7 or 8 months. And there's basically two things that we have to think about in terms of the actual hazard. There's two ways out from this. One of them is either through herd immunity, which means that 70% of us, 60 to 70% of us actually get the virus. And then the virus will have a hard time finding somebody to infect because we think you have a little bit of immunity after you get the virus, just a little bit. The second way is when we get a vaccine, assuming that the vaccine is both safe and effective. Having a good vaccine will give us another way out. And currently, there are 6 in the U.S. government program, Warp Speed, which is a program to develop vaccines. There's currently 6 candidates that are being looked at closely. Several of them are actually in trials. So remember, there's 2 parts to a trial. There is the part where you check for safety, and then the part where you check for efficacy, which is, does the virus prevent future disease? So there's possibly 2 ways out, but there's also the third possibility, which is there's no way out. The virus is with us. We don't have a vaccine. Although we're optimistic we'll have one. If you think about HIV, it's been 25 years and multi-millions of dollars, and we still don't have a great vaccine for it, or any vaccine for it. So that's the third possibility, that we have to live with this. So on the hazard side, we have two possible ways out, and then perhaps we have to live with this for a while. And the jury's out on what happens. Let's look at the risk reduction side. On the risk reduction, I want to just reiterate the concept of infective dose. And what infective dose, remember, is the exposure, the amount of time you're breathing in particles, and how many particles are in the actual air. What is the density? So if you have a high density of particles and you have a shorter time, you can reach the infective dose. Or if you have a low particle density, but you spend a really long time there, again, you can reach the infective dose. So let's just make this up. If there's 100 particles is an infective dose, you can get there. If it's 1 minute breathing 100 particles, you get there. Or if there's only 20 particles that you're breathing per minute, then it takes you 5 minutes. But as soon as you get to 100 particles, or whatever the infective dose is, you get sick. So just remember that, because we want to reduce the time and we want to reduce the particle density. That's the way you do risk reduction. So what do you need to look at as you try to reduce the risk to as low as possible? And we're going to go through this relatively quickly. If you have questions about it, please, because I want to make sure we have time for questions. We started a little bit late and I'm running a few minutes over. So you need to, when you're starting to think about how to reopen your venue or your entity, there is the legal standard of prudent layperson, which means that you need to do all the things to reduce risk that a smart, prudent, normal thinking layperson would expect you to do. And one of the things that's really required is a contract, a social contract between the venue operator and your patrons, because you can't protect them adequately without the audience or the patrons doing things on their side. So that involves pre-event communication. And there's a whole talk that we do about the digital journey that people go through on their way to special events. But part of that early communication has to be what the audience will expect when they arrive and what we expect them to do, like wear a face covering, for example, or socially distant or something like that. Or we're not having an intermission, which we'll talk about in just a moment. So you need to think about their journey and their digital journey. And then there are administrative and engineering controls that you want to put into place. And we don't have time to get into this deeply today, and maybe we'll do with some questions. But it involves reducing contact with the hazard. So you want to reduce cleaning. You want to actually reduce contact with infected surfaces by increasing cleaning. So you prevent touching something and putting it into your face. And then you want to think about, so that's all these things, rethinking intermissions, because that puts people close together and they're touching high touch surfaces at a bar or a food establishment. You want to think about your food and beverage. Again, you want to reduce contact with the virus. Right? Social distancing reduces the contact you have, the density of virus in the air, and how much you breathe into your body. So there are various ways, and I'm sure you've seen this in places where there's spots on the floor. For outdoor venues, I actually like this picture that was in the New York Times a week and a half ago of a park that had 6-foot circles where if you were in your circle, you could take off your mask, and those circles are 6 feet edge to edge. So people were doing good social distancing. But if you were walking between circles, they wanted you to put on a face covering. I saw a great example of how to do this actually at the West Point graduation, where they had 6 feet in all directions between each of the chairs. And when the graduates walked in, they were wearing face coverings. They sat down, they took them off. It was outside, so it was a good example of how to do that. Right? So the other things you need to think about on your administrative controls are about the house, the back of house, What do you do in bathrooms? We had some questions about that. But the key is you need to reduce the concentration of particles in the air. So we'll talk a little about rehearsals in a little bit. But thinking about all the questions we're going to get to now, I want you to keep in mind the way to reduce the risk is to reduce the time you're exposed and to reduce the concentration of particles in the air so we keep people from getting the infective dose. All right. I know I skipped through that because we want to leave time for questions, and some of the questions will get into the details. But this is me. Take down my email address. You can send me questions at info@icrowd.com. I'm happy to answer specific questions. You know, we'll answer questions from people in the audience. If you want us to write an entire plan for you, we'll probably ask you to hire us, but individual questions, I'm certainly happy to answer. I'm going to ask Annette or Erica to come on back, and let's spend the last 20 minutes talking through some questions.
Hi, Dr. Stu. I'm here. Hopefully everybody can see me. We have a few questions. I'm going to ask one, and then we'll move over to Simeon, who will ask one. We'll kind of go back and forth that way, if that's all right. Dr. Stu, if you could turn your video back on, though, yes, so that we can see your shining face, that would be excellent.
There we go.
So, as you're doing so, so first question, could you get into some of the specific protocols for theater, dance, music, and vocal rehearsals? The sort of spacing that's required, and basically, should all rehearsals be conducted outdoors?
So, yes and no. Let's start with the outdoor part. So right now, singing in an enclosed space seems to be a real problem. Unless you have 6 to 12 air exchanges at least, so that's a lot of ventilation, which would blow people around. You know, if you have like big whooshes of air to make an outdoor kind of environment, then you could probably practice inside. Or if you're in a huge hall with a really small amount of people, that's a way you could practice. But if you have a large choir or a big bunch of actors, most rehearsals should be outside. That would make it much safer. And it's getting to be warmer weather, so if it's not too hot, you can put up a tent without sidewalls to create some shade, but I would really recommend outdoor rehearsals. If you're going to practice indoors, you want to use the figure of 36, and this again is not science yet, but basically 36 square feet per person, 6 feet in all directions. So if you keep the density down to 36 square feet per person, and you have a really tall ceiling and a big space with good ventilation, lots of outside air coming in, then you could move some rehearsals to inside. Some of the guidance I've seen recently is have a 15-minute rehearsal and then stop, let the place completely air out, and then come back and do another 15-minute. Because again, we want to reduce the quantity of particles, and we want to reduce the time that actors or the other folks are in contact with those particles. So again, try and do rehearsals outside, and then if you need to do inside, you want to make sure that the rehearsals are time limited and that you have big quantities of air so that the density of particles doesn't get very high and you have good ventilation. Lots of windows open, or HVAC system, a heating, ventilation, air conditioning system that has lots of outside air coming in. A lot of the systems recirculate air because they want to save money, and you want to talk to the people in the venue and make sure that they open up the louvers and let in lots of fresh air.
Quick question, Dr. Stu, that was in the chat in regards to that first question that you just answered. If they are rehearsing at the 6-foot distance and the 36 square feet of space, should they all wear masks?
Yes. Again, the face, and I like to make a differentiation between masks and face covering. So face coverings prevent particles from coming out. Actually reduce particles. Particles still come out, but they're lower amounts. Remember that face coverings are not meant to protect you from breathing particles in. So you need to have everybody wearing a face cover, and that will actually, a cloth face covering, that will actually lower the particle density in the air. So if in fact you are doing 6-foot distancing and you have a big space with lots of air movement and ventilation, and you put face coverings, you will lower the risk down to a point where it should become acceptable. Now, the difference is if you have people that are singing, because singing, the particles come right out from the side of the cloth covering or mask. If you have people doing athletic things like dancing, that's a problem as well. Or if you have people doing close, intimate scenes, that also becomes a problem.
On that same line of questions, Dr. Stu, can you talk a little bit about any issues for safety, folks that have asthma, other health issues, vigorous exercise, and wearing a face covering? Are there any concerns that folks should have?
Yeah, it's a great question. Thanks, whoever submitted that. So here's the issue with face coverings. They increase the work of breathing. That is clear. So what I would want people to try and do is take it outside, go outside, put on a face covering, and then walk around vigorously or do some of the activities you're planning on doing with the face covering on and see how that affects your breathing. Some folks tolerate it pretty well, but there are some folks that have a real problem because it does increase the work of breathing. And therefore, if you have a underlying respiratory problem already, this could make it worse. And then you're not a person that can be working with a face covering on for long periods of time. So they need to try it in a safe environment and take it off if you're having significant problems breathing. That's the best advice. It doesn't trap carbon dioxide. There's no what's called dead space. It's not like you have a big bag over your head. If you have a tight-fitting face covering, the carbon dioxide goes straight out of your mouth into the air. It doesn't trap things. It just makes the work of breathing a little more difficult.
Great. Okay, another question from the group. Can you give info on the feasibility of back-to-back performances in the same interior venue on the same day? Do you need to take cleaning protocols between shows? And does the virus need to settle out of the air in between performances? How feasible are back-to-back performances on the same day in the same exact space?
So that's a great question. So there's two factors you have to think about with back-to-back performances. So the first factor is contaminated surfaces. So you have to make sure that you clean all the surfaces that audience has sat in. If it's the same cast, it's a little, you want to make sure you clean those surfaces as well, regardless. So you have to clean the physical environment. The second part is the particles, the aerosol particles. They can float in the air for hours. So what you need to do if you're going to have back-to-back is you need to actually make sure that not only do you clean the environment, but you need to wait. And the latest guidance I saw was 24 hours. That's what they're saying in some of the government guidance now, is you have to wait 24 hours for particles to settle. I have seen studies where particle aerosols are still in the air up to about 3 hours. So if you were to double that for safety's sake, if you were to wait 6 hours and had a very active air exchange with doors and windows open and big fans blowing the air and then on one side and sucking the air on the other side, and you could move all the air and calculate what an air exchange, if you could do a complete air exchange and clean the venue, then I think after 6 hours, it's probably okay to do another performance.
Dr. Stu, one of the paradoxes of this disease is that it's, as you said earlier, you can transmit it while you're asymptomatic. In light of that, are temperature checks still relevant, and are there other precautions that need to be taken?
So, great question. So temperature checks are part of the pre-entrance screening. It's not the be-all and end-all. So I'd like to always remind people that you don't want to just do temperature checks. Temperature check is part of the questionnaire that you should be doing and also checking their body temperature. Remember that somewhere between 50 and 80% of the people that get sick actually have a fever, but you spread virus. Seems like you can spread virus maximally right before you get sick. So we're not picking up everybody, but it's part of the question part, which is 2 questions you need to ask. The first question is about exposure. have you been exposed, or do you know anybody that you've come in close contact with that has symptoms of COVID-19 or actually has the disease? So exposure is number one. Have you been in contact with anybody that has it? Number two is, do you have any of the symptoms? And there's like 11 symptoms now. The CDC changes it, but if you combine them together, you can come up with 11 symptoms. Usually we advise clients to put the symptoms on a sign, and you point to the sign and you say, have you had any of those symptoms in the last 14 days? Have you come in contact with anybody that is known to have COVID-19 or suspects that they have it or is tested positive? And then you take their temperature. The combination of those two things should take about 15 seconds, and that adds to your reducing the risk that you're going to have somebody sick in your venue. It doesn't reduce it to zero, but it's part of the process to reduce the risk. So I think right now, until we have point of care lab testing where we can actually swab audiences' throats and see if they have SARS right now, I think temperature testing is part of the entrance process. That makes sense.
And then we have one more question before we get to the growing Q&A. Just a reminder, please place your questions in the Q&A section, not in the chat. What kind of guidance can you give to performing arts summer camps that might be planning to occur in interior venues?
Yeah, so summer camps, what my first thought always is, do it outside. You need to, if you're going to have performing, I'm guessing that you're talking about performing arts camps, or are these summer, do we know about the question?
Performing arts, yeah.
Performing
So
arts
musical
camp,
theater, singing,
musical,
dancing, acting.
So the kids, and we're seeing actually a shift to younger people now in this wave of, in this continuing first wave of COVID-19 that we're seeing. So kids are going to be doing activities that create maximal numbers of droplets. So you really have to think about how are you keeping the density of droplets from building up to a really unacceptable level. So, you know, in dance, in live theater with you know, lots of activity, in singing, all those activities are putting out lots and lots of particles. So you need to do it outside is my number one guidance. And be creative. If you can come up with venues that have, again, just coverings for sun and shade, it's challenging to think how to do this, because I know a lot of the summer camps, performing art camps, use indoor spaces. If you're doing indoor spaces, you want to make sure that they are well ventilated, that you maintain at least the density of no more than one person per every 36 square feet, that you actually have lots of air exchanges, and that you do a 15-minute rehearsal, and then they go outside and the air gets exchanged. The same thing we already talked about, because you don't want the kids bringing this home to their parents, and especially their grandparents, because you'll end up with a summer camp that becomes a super spreading type of environment, and that would not be good for anybody. So not a lot of good guidance there, and I'm sorry, there's not a lot of science on this yet, but the key is to try and do those higher risk activities outside. If you're doing one-on-one coaching, again, if acting, everyone should be wearing face masks, but face coverings. If you're doing one-on-one where they can't wear a face, then at least the coach should be wearing a face, a face covering, lots of ventilation, you know, in that space. But it's better if both of them are wearing face coverings if you're doing one-on-one coaching indoors. But do not do it in a soundproof room that has not good ventilation, because that's a perfect setup for catching COVID-19.
Great, thank you.
A couple of questions came in about using UV light. And I know there's been a couple of articles about UV light as a way to control the spread of the disease in interior spaces. Can you talk a little bit about that?
Yes, that's called upper room UV lighting. It's been a concept that we know about for a really long time in healthcare. So what happens with aerosol particles is they come out of people's mouth, and then they're lighter than air in general. So they float up. UV ultraviolet light is actually dangerous to our eyes. So having it down at head level is actually, or below, is actually dangerous. But if you actually have a big open space with a high ceiling and you can mount UV light, 10, 12, 10 feet up, 8 to 10 feet up, and you'll have to get an engineer in to figure out exactly where these lights should be safely placed. But then when the particles float up, the UVC light will kill the germs. And then when they settle back down again, the germs are dead. So it's a high room, upper room UV is actually a solution in a high ceiling space, but you need to get an engineer in there to figure out exactly the characteristics of your space. We have some environmental engineers that we know. We can point you in the direction if you don't have one, depending on where you are. But upper room UV light is actually a solution to removing the concentration of active virus particles in rooms.
Dr. Stu, are you okay to overrun till about 12:15?
I am.
Great.
If everyone's willing to stay on, I certainly am.
We have a ton of questions in the Q&A. I'm wondering if you can click on there and maybe find some that you might like, or Simeon and I can read them off.
Yeah,
for
if you wouldn't mind going through them. It's challenging with our system with the problems we're having. I can't get into the Q&A.
Sure. So I will start. Gosh, okay. Do you think it's reasonable to ask patrons to wear their masks while seated and watching a performance?
The answer is it's face coverings, not masks. Remember, masks are N95 masks. They're tight fitting and fit tested. These are face coverings. And yes, I think it is reasonable and it is part of doing your due diligence to actually request that the audience wears a face covering while they are in your venue. Unless they're sitting 6 feet apart and they are outside, you want to keep them from putting out lots of particles. So I think it's actually pretty reasonable to ask them to do that. It's actually a revenue generator. You can actually brand them and sell them if people don't bring their own face coverings. It's actually something you should be doing in the pre-event communications. Part of your digital journey should be requesting people to bring their own face coverings when they come. But I think it's actually reasonable to ask them. The other thing is that we didn't talk about intermissions, but one of the things I would tell people to consider is not having an intermission. And I know that's hard for some venues because they make a considerable amount of revenue on food and beverage during intermissions. But the problem is, unless you can do it outside and have social distancing, people will take off their face coverings while they're eating and drinking. So it increases the risk.
Dr. Stu, a number of questions came in about whether face shields are a sufficient substitute for face masks. Can you just talk about face shields and whether they have efficacy?
Right. So face shields prevent people from spitting on each other. So if you're doing something loud and you're talking at somebody, that prevents the actual spittle from coming out of your mouth and going into somebody's eyes. What it does not do is anything to do with aerosol particles or the smaller respiratory particles, because they will come out of your mouth, go underneath the bottom of the shield, and go right out to the environment. So what we recommend is face shields plus face covering, not in place of. Unless you have a face shield that has a cloth that goes all the way down and tucks into your costume or your shirt, then you have the same thing as a enclosed face covering. But what I see people doing is having a face shield with an open bottom, and then the particles just come right out. So you're not doing anything.
Thank you. There's a question about back-to-back dance classes. You had answered whether back-to-back performances in the same venue was feasible, and you'd said that it's probably not a great idea because you need 6 hours minimum for the virus to settle out of the air. Does that also apply for dance classes?
So dance classes with a smaller, again, with the 36 square feet per person indoors, what the latest guidance I've seen, and this is more for rehearsals for movies, but they did some really good research. The Directors Guild and SAG-AFTRA did there's a really great document. If you want to download that, you can take a look at it. But they recommend rehearsals, and I agree with them. So 15-minute rehearsal, then you open all the doors and windows, clean the stage, and air out the place completely for I don't know how long, it depends on what type of air ventilation system you have. So make sure you have an air exchange. You clean out the air completely with fans, then you come back in and you can rehearse some more. So you want to limit the amount of time you're in the space, and you want to reduce the amount of particles. So people have to work out, and they can send me individual questions and we can talk about it individually. But in general, the process is clean the space and air it out, and then you can bring in a more rehearsal.
One question that came in, pretty critical one for some of the interior performances.
I'm sorry, Simi, can you speak louder? A little
Yeah,
louder.
sorry about that. One of the questions that came in is about managing the entrance and exit process. So assuming that you can get people to distance while they're in the venue, high density situation when people are coming in and leaving, how should folks manage entrance?
Yeah, it's a great question. Great question. So that's, again, part of the pre-event communications. So what we're seeing different clients do, and what seems to be the most successful, at least in the planning stage yet, is to give people arrival times, if you can do that. So if you have a big parking lot, what people have been doing, some people have been doing, is texting folks when it's their time to come in. So you give them a time that they're supposed to show up, and then you text the person during that time and say, come on in now, there's no line. What you want to avoid is a pinch point and a line, because you don't want people to get all nervous that they're standing too close together and going through a narrow doorway. So having times, and you can make the times short, like, you know, you have a minute or two to come on in. We're going to text you. We're going to tell you to get out of your car. If they're coming by other means, like here in a dense city, again, giving them times to report. And it's a balancing act, because the people that come early are going to be sitting inside of a venue longer. But you want to prevent lines. So when you're designing your ingress, generally you want to give them times to report. That seems to be one of the successful ways of doing it. Making sure you have more doors that let people in. That's another way. So some of the doors that you may not normally use to let people in, try and find ways to do that. Look at the pinch points. So if you have a slow bag check inside or a slow coat check or something, you want to get rid of those pinch points by perhaps doing bag check on the way out with stickers. You can put a checked on the outside of it already, or something that does it in advance. So you need to walk through the journey that your audience will go through and take a look at it from the standpoint of, how do I reduce pinch points and prevent crowds from forming here, or lines? And everyone's individual situation will be different, but there's some good strategies people can use.
We're getting quite a few questions in regards to plexiglass. We had one question from a theater that's planning to install plexiglass partitions on stage and also between the audience and the performers. We've also had some questions from musicians who are asking about plexiglass shields that are of music stand height. How effective is a plexiglass shield?
Right. So let's talk about musical instruments first. For non-woodwinds and brass, if the musicians are 6 feet apart and wearing a face covering, then that should be fine. Again, if you have a big hall with good air, again, the ventilation is really important. So you can't squeeze a lot of them into a small room, right? I'm talking about big space with lots of ventilation. If they're sitting 6 feet apart with a face covering and they're playing the violin or the cello or non-woodwind or brass, they're okay. Percussion's okay. The problem you get into is with the woodwinds and the brass. And the studies there's not a lot of science about that right now. Now, you may want to put plexiglass between them to prevent droplets from directly going, because a lot of people clear their throats or cough when they're doing a lot of playing of woodwind instruments or brass specifically. Sometimes they cough, they have to clear their airways, and you want to prevent ballistic drops from shooting from one person to the other. So putting plexiglass between brass players and between woodwind players is not a bad idea. It's not going to do anything for aerosols, which will float right over the plexiglass. So you got to make sure you have good ventilation going on, and 36 square feet per person as the density. Don't crowd more people into a small space. Tell me the first part of the question again.
So there was a theater who was looking to install plexiglass in between its performers on stage and also between the performers and the audience.
Right,
yeah.
That's right. So performers on stage, plexiglass is not going to help that much. If they're already wearing a face covering, you're going to prevent most of the droplets from coming out of their mouth. Face coverings, if they're made properly, and the CDC has some guidance on how to make a good 3-ply face covering out of cloth. Go look at that. But that prevents a lot of those big droplets from coming out. I don't think adding plexiglass in that situation is going to make a lot of difference. I do not think that in a space with good ventilation, adding plexiglass between the audience and the performers, unless you have made a complete box on stage with its own ventilation system and you're performing inside of a fishbowl that's sealed, if you just put a piece of plexiglass in front of the audience, it's not going to add a lot of value. Unless the performers are, sometimes if I sat in the first row and they're singing really loud, I can see the spittle coming out, landing on me previously. So unless you're doing that, but hopefully people are not doing that. So other than that, plexiglass between the audience and the performers is not going to add a lot of value.
Dr. Stu, there were a number of questions that came in that kind of knitting them together. The theme is the extent to which being outdoors mitigates a lot of the distancing or not. Can you just talk a little bit about how strict folks need to be when they're engaged in outdoor activities?
Right. So we still recommend the same types of coverings. So the same kind of precautions. So face coverings and distancing is still important even outdoors. But because you're outside, you are significantly reducing the risk of big particle densities. If people are 6 feet apart outdoors, they can actually take off their face coverings and be okay. Because generally right now, in an outdoor space with 6 feet of separation, you don't need to wear a face covering. If you get less than 6 feet, even outdoors, you need to wear a face covering. But the guidance right now is in an outdoor space, because it's so much air volume, if you're 6 feet apart, you can actually take off your face covering and be relatively safe. Now, having said that, if they're doing high risk activities like singing, I would want to give them a little more space. I would probably go to 10 feet. And this is just me saying it. I would go to 10 feet if I was really worried about folks singing, and 10 feet in all directions, especially in the direction that the particles are going. So it's not just side to side, but it's front to back also. I would probably increase that if they're doing really high risk things. But 6 feet outdoors without face covering is actually okay if they're just talking or rehearsing.
Two questions that are kind of related and that you've talked about in your weekly webinars before. And just so you all know, in the chat, I've cut and pasted a link to Dr. Stu's daily newsletter. And he also does a weekly webinar that I personally find helpful on Fridays at noon. It's free and it's quite settling. So a question about the cumulative nature of the virus in the air. You had indicated before on your weekly webinar that it's less contagious than measles. We don't know how many particles yet are needed for infection, but can you just clarify, is it cumulative? So does it add up over time? And also, as an effect of that, what sort of protocols are you seeing for bathrooms?
Right. Okay, great questions. So just my weekly webinar, it's actually not even a webinar, it's the weekly Friday wrap-up chat. And basically what I do on Fridays, for 20 minutes, is short and sweet. I go into questions that people have sent me or relevant topics that are important in the news, and we just have a conversation for 20 minutes. It's a way to end the week, just wrapping it up. So, the more people, the merrier. It's quick, it's 20 minutes at noon on Eastern every Friday. Particles, we don't know the number of particles yet. We know that it's more than one, because with measles, for example, we think if you get one measles particle, you get sick, right? Measles is really, really contagious. And there's other ones that are like that, that are chickenpox are pretty contagious. There's a couple things that are. We know that COVID-19, you have to get a certain number of particles. It doesn't, as I said before, it's a combination of time and density. So if, let's just pick the number 100. There's many ways to get to 100 particles. As you get 100 particles in your body, it overwhelms your immune system and you get sick. So if it's a low density and you're there for hours and hours, you'll breathe in the required number of particles to overwhelm your immune system and get sick. If you're breathing in somebody who just sneezed and there's 10 million particles per square meter of air, and you walk into that and take one breath, you're going to get more than 100 particles and you're going to get sick. So that's why we want to reduce the time and reduce the density to reduce the number of particles, right? And then there was a second part of the question. Sorry.
It was the bathroom issue. And you've also talked about how porta potties should be our friends too.
Bathrooms. Great question. So here's the news with bathrooms. Although they're less wonderful, porta potties are actually safer from several standpoints. And here's the reason. Although you have to worry about the contact touching a porta potty, which is why, you know, many of us do that, lining the seat with toilet paper thing, with overlapping sheets of toilet paper and the whole thing, right? You don't create aerosols when you use a porta potty. The problem in a modern bathroom is those high pressure, wonderful modern toilets where you hear it go whoosh as you flush actually create thousands and thousands of microscopic aerosol particles out of what's ever in that toilet bowl. And we have already seen that COVID-19 virus particles are in stool or in poop in sick patients. So you are putting, so for God's sakes, if you're in a place that has a toilet seat cover, put down the toilet seat cover before you flush the toilet. The other thing that's really high risk in those bathrooms is the modern jet air blowers for your hands. You know those fancy things you put underneath and it blows like an airplane engine? Well, that has been shown to spread multitudes of particles around the bathroom. So what we are recommending is paper towels and turn off those jet hair blowers, hand blowers. Turn them off, put out paper towels, much safer. So if I had a modern bathroom now and a porta-john, I used to always go for the modern bathroom, but now I'd probably go for the porta-john, making sure I washed my hands carefully after I used it and lining it with all the toilet paper thing.
Dr. Stu will end with the unfair question of the day.
Oh, no.
One of the questions that came in, do you have any prediction when in the future we might be able to go to something that resembled normal, just in light of the current science, in light of what's progress is being made on vaccines? Is there any sense 2021, 2022, perhaps beyond, given the three options you gave us earlier?
Yeah. Okay. So that's the crystal ball question at the end. So let's go into this a little bit. Here in the United States, and for those of you that are in other countries, this may not apply, but here in the United States, we are not, as a society, doing a very good job of containing the virus. Because right now, as a country, we are not doing the things we need to do to break the chain of infectivity. So if you look at Iceland, for example, or Australia and New Zealand, they are back to full restaurants and performances and the whole thing, because they have had no cases for a long time, especially in Iceland, and because they are doing vigorous contact tracing and vigorous isolation and quarantine. We are not doing that consistently across our country. So if we decide to do something different, we could actually start attacking the hazard side of the problem, and that would get us to this solution faster. But let's assume that we continue doing what we are currently doing, and we see, well, we used to see 20,000 new cases a day, and now we're actually seeing 30,000 cases a day, not due to increased testing, we are going in the wrong direction. So we are going to probably see a continued first wave without any decrease over the summer. And then we're going to go into the fall, and then we're going to add seasonal influenza on top of it. And we're going to have some issues in the fall. I think the break will come when and if we develop a vaccine, which should be, if we get good data, in the first quarter, hopefully, of 2021. So again, crystal ball reading is always very hard to do. But if we have good vaccine data, and remember, we have to do the safety side of the vaccine trials to make sure injecting things into people are not dangerous. We have experience having developed vaccines in the past that actually turned out to be dangerous. And they had to be withdrawn. Like, for example, the SARS virus 10 years ago, they had a vaccine that actually, when you got the vaccine and you got SARS, you actually had a worse reaction because it revved up your immune system so much that it attacked people's bodies. So we have to make sure the vaccine is safe, and then we have to make sure that it actually prevents people from getting disease. So it has to be safe and efficacious, and that takes months to do with thousands of volunteers. So I think the first quarter of 2021 is the earliest we could have a full vaccine if we keep doing the same thing that we're doing now from a public health perspective. If we change our mind about that and we do contact tracing and some of the other public health things that we should be doing across the country, then maybe earlier, but I'm not seeing that happen right now. So I'm thinking the first half of 2021 at a minimum.
All right. Thank you so much. Thank you for all of us who stayed with us. Thank you, Dr. Weiss, for providing so much valuable information on such a big array of questions. Thanks to Erica and Simeon for making sure we got to as many questions as possible. We certainly want our arts organizations to remain viable and continue to contribute to all of our communities and get through this pandemic. I just want to note again that we will be posting the recording. We will also post links to all the handouts. Some of them are already there at our acf.org. We'll also post the link to Dr. Weiss's Friday session. Specific questions, remember Dr. Weiss said email him at info@icrowd.com. And thank you all for joining us for this really important conversation. Again, thank you, Dr. Weiss, and have a great day.
Thanks for having me. Take care.
Take care.
Thank you.